All right, so yeah, this is called Fast PWAs with Angular and Ionic. Mike Hartington, if you do want to see pictures of my cats, random stupid things I do online, follow me. I judge my self-worth based on how many Twitter followers I have, so help me feel good about myself. So I wanted to start off by trying a little experiment. This could go really well, or it could go horribly wrong, so let's try it. Okay, so experiment worked. We all just waited 14 seconds. I wasted 14 seconds to illustrate a point. Have you ever been on a really slow website or in a place where the internet isn't that great? You could be at a conference, or if you're like me, you're traveling and you're on airport Wi-Fi, which is horrible. 14 seconds is basically what a lot of people have to deal with, whether it's crappy internet connection or just really slow, large websites. There was a report that came out a couple weeks ago that a typical app will send down megabytes of JavaScript code over the network, whether this is Wi-Fi or your actual cellular data. And this takes a lot to load, a lot to parse, and just really a bad experience. It gives the mobile web a very bad name. So to work around this, there is this idea of PWAs, which provide an optimized experience for devices that are not as fast as, say, an iPhone 10, but networks and networks that aren't as reliable as being hardwired in. And they often are much smaller than their native counterparts. I think the study was the Twitter PWA is 300 kilobytes. The Twitter native app is 300 megabytes that you're paying for to download with your data, but that's fine. So this begs the question. What's a PWA? It's an acronym, or it's a way to say progressive web apps. They are a way of building apps for the web that have a few characteristics about them. They are fast, meaning they are optimized for low-end devices, bad networks. They're progressive, meaning that it can use new features on the web today, and if those features aren't available on a certain browser, Safari, the app should still work, and there shouldn't be any issues. They're also secure, meaning that they're constantly served over HTTPS. And this is such a big point that certain browsers will disable APIs. So if you want to do anything with geolocation, you're going to need HTTPS because Chrome will block that out altogether. So it's that important. And they're installable, meaning that if you are using a progressive web app enough, you can add it to the home screen. It gets installed on your device. So if you're using Android, it'll show up in the app picker, and it feels like a native app, but just using web technology. Okay, so these are characteristics, but what actually is a PWA? A very smart person said that it's essentially a responsive website with some new capabilities. And an even smarter person just said marketing words. So it's ideas and patterns for how you can build stuff for the web and have it work in a worst case scenario and then a best case scenario. Okay, so we know what PWAs are now, and we're not building a PWA, we're building a website that is treated like a PWA. But how do we actually build a progressive web app? We're going to use Angular and Ionic, of course. I just happen to work for Ionic, so I'm going to use my company's stuff. Okay, and this is an Angular conference, so let's use Angular. But we also have great tools available because we're using Angular. And we'll take a look at what those are as we go along. So we are going to have 3 points that we want to hit. We want to make sure that the app we're building is integrated. We want to make sure that it's offline. And we want to make sure it's fast. So if we can hit these 3 different points, I think we'll have a solid PWA. And just to show the app that I've been building for a couple months now, which was my test case for all this stuff, let's change to the browser. So this is an app I built. Yeah. It's basically an app that I can just go out, look up a song, save it to like my list over here, and just reference it later if I want to download it. So let's get started. If Michael is in here. Is that the name of the song? River flows. Come on. Yes. This is for you, Michael. Okay, so let's save it to the favorites, go all the way back. Just to prove like it's a very fast app, let's open up Chrome's network tab, and we'll go ahead and just make it really slow. Okay, so it's already loaded. This is simulated 3G, so it's not perfect, but it still works. So the app loads less than a few seconds. Good experience. Let's go back to the slides. So we're going to tackle these kind of one by one. And we're going to start off with integrated. So this is how we can take our app and make sure that it is able to detect features from the browser and be installed on the user's device. To do this, the main technology is going to be the manifest. So this is a JSON file that you can declare in your inside of your app, and it describes all these different characteristics that your app could have, like what is its name, what kind of icons does it have, what's it going to look like when someone adds it to their home screen. A few other things here and there, but these are the main important ones. And this is the one that I'm using for my app. So I'm just using the name, short name, startup URL. For hosting reasons, I have to set it to index.html. Not sure why, but it works. Display mode, so I can say, hey, when I'm installed on a user's device, don't show any of the browser UI. Just get rid of it. I don't need it. Orientation's pretty self-explanatory. Icons, again, self-explanatory. And then background and theme colors set the styles for the browser window and then also the splash screen that gets generated for us. So we have the manifest file written out. We add it to the browser to our index.html by using link-rel manifest and just passing the path to that file, and it's already handled. So if you remember the old days of iOS having 20 different meta tags, this is a much better approach. So let's take a look at what this actually looks like in practice. Okay, so the app isn't even loaded yet, but we have the status bar of my phone and the actual URL bar automatically changed, updated. It read that from that manifest. Pretty nice. Okay, the app is loaded. Let's close it out and check out the home screen or the installed version. So this is a splash screen that I did not have to make. By just supplying the icon, it automatically built this for me. So the platform doing something good. And then we'll see the example of the app in standalone mode. So notice this is still being loaded inside of Chrome, but there is no Chrome tab bar or URL bar. It feels like a native experience by just using what the browser has. Okay, so that's really all there is for making it kind of integrated and feel installable and using those features. What about making it offline? To do that, we're going to use service workers. And service workers are difficult to explain. They're complex. But the easiest way that I can think about it is it sits in the middle of your app and the network. You can tell it to do things, The service worker can automatically do things or modify any external requests or any requests that are that could be made in the future. And it's primarily known for being a great place to store assets for cache, but it can do a lot more. So to get started with service worker, we're going to just do some of the feature detection. So part of being progressive is that if there is no service worker in the browser, we shouldn't fail or attempt to install it and throw an error. We can just conditionally watch that. So we have service worker, we'll register our script, and that returns a promise which we can handle. But what does the service worker itself look like? Well, we have a similar idea to a web worker, where we don't have access to things like any DOM methods. We basically have this encapsulated script that can publish messages and have its own execution context, but not interact with the actual app itself. So what we're actually doing here is creating something called a pre-cache, where we are saying, okay, the service worker has been registered by the browser. Open up a cache, and then after that has been done, we're going to call cache.addAll, and we are going to include our main JavaScript file and our main CSS file. So before anything has even been done, these are already in the cache. They're already stored. If I go offline, the main JS and the main CSS are already there. And then we can close it out by just saying service worker is ready, assets are cached. And this is taken from a site called servicework.rs, because we're clever programmers. It's simply clever. So it's a site that has a whole lot of ideas, patterns, and tricks that you can add to a service worker, like handling caching, handling whether or not an external resource should be grabbed from the server or from the cache. It's got a lot of things on there, but service workers, again, are very complicated. You can go simply from having a 15-line service worker file to maybe a 500-line service worker, and that's just to deal with the cache, which is not great. There's a lot of libraries out there that you can use. A real popular one right now is called Workbox by the Chrome team. But we are in Angular, and of course Angular has a library for us. So we can install npm, we can run npm install @Angular service worker, and this will give us everything that we need for working with the service worker, but none of the headaches that come with actually writing a service worker ourselves. So instead of it being all about code, we have JSON, which is a much better way to handle this. We can start to do things like glob patterns for all of our resources. So I want to get any JavaScript file, no matter how deep the directory is. We can handle assets being pre-cached or lazily cached, or even caching external API responses. And then once those assets are cached, we can start to mess around with, okay, if it's 5 days old, delete the cache and go to the network, or okay, should I go to the network first and then the cache? How to handle this response? And it's all just done with a simple cache age, 5 days. Very straightforward. So again, JSON, I said, we have our starting point for the app, and then we also have what's called an asset groups. Now these could be assets local to your app. In this case, I have all of my CSS, all of my JavaScript, and the index.html itself. All of them are being cached as soon as the service worker has been created. We also have this other area down here in the bottom called data groups. So this is anytime you make a request to an API, you can control all of those aspects. So for my app, we have one for the API I use to get all the music. So even if I were to go offline, I could still type in a song, and it would return that data from the API. I couldn't actually play it, but I can still use my app. And then to actually use it inside of our Angular app, we're going to go to our root ng module, import the service worker module, and then add it to our imports. And because we're not going to try to use it during development, because how great would that be if parts of our app are already cached while we're working on it? So we're only going to enable it if we are in production, and thankfully the Angular CLI takes care of all this for us, so we don't have to worry about generating this service worker file. It'll actually just read the JSON file that we have and generate that based on it. And it comes with two classes that you can import, SW update and SW push. So with SW update, you can manage how updates are being applied. So if you go load a site and then, hey, there's a new version of the site or there's something out of date, you can throw up a little window, a little alert saying reload the page to get the fresh content. Again, I said service workers can do a lot of things, and one of the better things is that they can do push notifications. So there's also a class for handling push notifications inside of your app, which is because who really wants more notifications on their phone? It's a thing that you can do. Okay, so our app can be installed. It can work offline. How do we make it actually fast? This is really the part that I struggled the most with, because I had to change a lot of the code I wrote, and also how I used other people's code. So the main goal that we want to kind of hit is to just ship less code altogether. We can make a very fast website if we ship no JavaScript. It's not going to be a really great site, but it'll still be fast. So we can find the right trade-offs where we are picking certain libraries because they're better and smaller, and lazy loading everything so that way we are not making that single main.js a couple megabytes. So who's used Moment.js? You all should uninstall it. Moment.js is 335 kilobytes by itself, which is huge when you consider some of the pages on this app are 10, 12 kilobytes. So imagine having an entire library which includes all the core functionality plus dealing with locales. That's a really big library versus using something like dateFNS. If you have not heard about dateFNS, it is far superior in every single way, and I will go to my grave saying that. But they have a different import style that you can use. So when you are importing this, the library, instead of importing the entire thing, you can pick and choose what functions that you want. So this is actually just using the base format function that they have. So we're importing from dateFNS ESM. I'm importing format, and when I ran through the build, ran everything through the build, I was able to see that it was only affecting it by 23 kilobytes, which is far better than 335 kilobytes. Lodash. Who's used Lodash before? I've used Lodash far too many times. Lodash is great because sometimes browsers' built-in methods are very slow. Lodash is very fast, but Lodash is also 70 kilobytes, which is far less than Moment, but still, every kilobyte counts. So what we do, we actually install Lodash ES. It's actually by the same author, which is great. So instead of importing all the functions and all the methods that Lodash has, we can just import the single function that we need for our use case. So when I installed Lodash, I had about plus 70 kilobytes, and when I switched to Lodash ES, I was using about 5 kilobytes, and that was just a single import. So much better. Still wish it wasn't 5 kilobytes, but you do what you gotta do. In fact, the only kind of plug I'll make for Ionic is this is how our entire component set works. Is instead of you including all of the codes for every component, because we have about 90 components, instead of including all that together, each component file is just a simple set of rules like, okay, here's all its valid inputs, here's all of its valid methods. When this is rendered, or when this is created, just go and lazily load this. So we can take what could be a megabyte of JavaScript and CSS and make it a lot smaller and only load the components as we need them. So there's tools that you can use to kind of figure this stuff out. There's the Angular CLI budgets. If you follow this bit link, there's a great post by Thomas Trajan? I don't know. Post by Thomas, where he went through all of these things that you need to do to get the budgets working. Definitely worth a read. And if you do read it and you like it, tweet at him. He loves to know that. And then there's also Source Map Explorer. So this is how I was going through and analyzing my bundles. It'll go through and it will generate all the like a graph, basically saying, all right, your app for this or this piece of code is 15 kilobytes. Here is where those 15 kilobytes are coming from. It's definitely a great tool. You should be using it. Lazy loading. Who's using lazy loading in their apps right now? This is far more than I see. That's good. I wish everyone's hands were up, because you should be. But every time I'm working with developers out in my community, the first thing they say, oh, my app is slow. It's like, are you lazy loading? No. Well, there you go. Lazy loading can greatly reduce that main bundle size. And that's, again, the real goal is it doesn't matter how many different chunks you have. If you have a large app, it's going to have a lot of components. But if you could split that up and make the cost of components much smaller, you can do this with lazy loading. So for my app, this is really the only lazy loading I actually needed to do. I created a shell page, which it has nothing in it, no functionality. It's just a, hey, go to the site. I'm using a lazy loaded module for the searching, and then for the actual detail page, that's its own lazy loaded module. And to make sure that I'm actually having them all ready and just kind of, I can navigate to it instead of having to want to navigate, wait, get the component, and then go. I can work with a preloading strategy to actually get these preloaded in the background when the network is good. Another approach that you can kind of do to make this a little bit easier in the meantime is you can group common components together. So if you have, say, a user tab bit of UI, and each one of the tabs are a separate component, put them in the same chunk. Again, it's not about shipping overall less, it's about making that initial load fast and by making the main JS smaller. A little plus that you can do, if you look into HTTP2 push, which is really hard to say. So H2 push. It's hosting specific, so depending on what provider you use, they may support it or they may not. And not every browser actually supports H2 push yet. Chrome does, which is good because it's one of the bigger browsers. But it's kind of a pain to set up. So to fix that, I wrote this little tool which will go through and analyze your website, figure out what the main resources are, and it will spit out or it'll automatically edit my Firebase hosting config to include the H2 push rule set. So I can automate it. It runs less than a second, and I have everything loading faster. For those who don't know what H2 push is, instead of setting a request one at a time, you can say, okay, if I load index.html, load all these other assets in parallel. So you can have all this content available for you. So those are the steps I took to actually make my app, Progressive Web App, and to improve its speed, performance, and make it installed on my phone. How did I do? It wasn't overly difficult. On web page tests, I have A's across the board. On the performance metrics, 91 is fairly good. This I still need to work on. So I have 3.5 minutes or 3.5 seconds of delay for the meaningful paint, but that can be improved. But progressive web apps, 100%. First content paint, less than just under 1.5 seconds. Pretty good. So bonus round of things that you can also look at that I didn't get a chance to talk about, but I want to look into them myself. Like Wasim said, we have add Angular PWA. This will automate everything from adding the service worker for us and also adding a manifest with some predefined icons. Use it. That's how I used it. For my app, it's much easier than having to write this stuff yourself. Server-side rendering is also important. There's a talk about that tomorrow that you should be around for, but we can start to send down static HTML instead of having to wait for the browser to parse our JavaScript. If we just send down static HTML, it's much faster. And on the same thought process of server-side rendering, there is a community library called NgToolkit, which is a set of schematics for working with Angular Universal. Much easier than having to write it yourself. So let's just take a second and think about this. That 14 seconds kind of seemed funny at the time, but that's someone's actual daily process. Me coming from the airport to the hotel, I had to wait forever to make sure that Twitter could load so that way I can get in contact with the person who was picking me up. And that was just not fun. So if we optimize everything and create faster apps, everyone has a better experience. Thank you.